In problem number 1, they are asking us what volume of water has the same mass as 100 cubic millimeter of gold and the specific weight. First of all, we have our data that it's volume density of the gold and the density of the water. For mass, we need to clear it for mass, and we have the formula of mass equals to density times volume. We substitute our values, the density of the gold times the volume that we have in here, and we have our mass. Then, to know the volume that we are looking for, we use the formula of mass over the density, and we're going to substitute our values, the mass that we already got, and the density of the water, and we have this result. Then, to have the specific weight, we're going to use the formula of density times gravity, and we are going to use the density of the gold times the gravity, and we have this result. In problem number 2, they are asking us for pressure and force. We have our data that it's height, area, and density of the seawater. To take out pressure, we need to use the formula that is pressure that is equals to density times gravity times height. We substitute our values and we have this result. Then in force, we have to clear out for force, and we have the formula that it's force equals to pressure times area, and we substitute our values and we have this result. In problem number 3, they are asking us for force 1. So we have our data that it's radius 1, radius 2, we have mass. So first of all, we need to take out the area. That here we have area 1 and area 2. Then we need to take out the force 2 with the formula of mass times gravity, and we substitute our values and we have this result. Then with the Pascal formula, we need to do this. If pressure 1 equals pressure 2, and it's force 1 over area 1 equals to force 2 over area 2. Then we clear out for force 1, and we have a force 1 equals to force 2 over area 2 times area 1. Then we substitute our values, and then we have this result. In problem number 4, they are asking us for pressure. So we have our data that it's radius 1, radius 2, and the mass. So we're going to calculate first the area 1, area 2, and the force that we have to use the formula of force equals mass times gravity. So we substitute our values and we have the mass and the gravity, and we have the result of force 2. Then we need to use the formula of Pascal, and it's pressure 1 equals pressure 2, F1 over area 1 equals F2 over area 2. Then we can substitute in order to find force 1, and we have the values that it's force 2, area 1. We substitute our values and we have it, and then we divide the result of force 1 over area 1 and the force 2 over area 2, and they will give us the same result of pressure that is equals to this. They are asking us how much does a globe can take. So we have the data that is density of the air at some altitude, the volume, the density of the helium, and the weight. So the formula that we need to use is buoyancy force, that it's density times volume times gravity. We substitute with our data that it's density of the air, then the volume, then the gravity, and we have this result. Then we make a subtraction between the buoyancy force and the weight that we have, and we have this result. Then we need to use the formula of the force, that it's mass times gravity, and we need to clear out for mass, and we have force over gravity. We substitute our values and we have the mass. In problem number 6, they are asking us how much extra mass does the balloon can have. So we have the data that is the density of the air, the mass, and the radius. First of all, we need to take out the volume. That is this formula, and we have this result. Then we need to substitute our values in the buoyancy force, that is density times volume times gravity. We substitute with the density of the air, the volume that we got, and the gravity. Then we have this result. Then we need to use the formula of force, that is force equals mass times gravity. We substitute our values, 50 kilograms, and the gravity, and we have this result. Then we need to make a subtraction between the buoyancy force and the force that we got. So when we substitute our values, we subtract them, and we have this result. Then in order to know the extra mass, we're going to clear for mass, and we have force over gravity. We substitute our values, and we're going to have this result. In problem number 7, they are asking us how much time does it take to fill 20 liters. So we need, first of all, we have our data that it's radius and velocity. First of all, we need to calculate the flow rate, that is with the formula flow rate equals area times velocity. We need to take our area, and we got this result, and then we substitute our values. Here are, and then we have our flow rate in cubic meters per second, but we need to take them in liters per minute. So here we have the conversion. Then, in order to know time, we need to use the formula that is flow rate equals volume over time. So we are going to clear out for time, and we have volume over flow rate. Then we substitute our values, and then we're going to have the time in, we can have it in minutes or in seconds. In problem number 8, they are asking us to take the flow rate. So we have our data that it's height and area. We need to first take out the velocity with the formula of square root of 2 times gravity times height. Then we need to substitute our values, and we got the result of velocity. Then in order to take the flow rate, we need to multiply with the formula velocity times area. We substitute our values, and we have the result. In problem number 9, they are asking us for two things, velocity and volume. We have our data that it's radius, height, and time. First, we need to take out the area. That is take out with p times radius to the square, and then we need to take out the velocity first with the formula 2 times square root of 2 times gravity times height. We substitute our values, and we have the result. Then to take out the flow rate, we need to multiply velocity times area, and we use our values here and here, and we have the result. Then, in order to take volume, we use the other formula of the flow rate, that is flow rate equals to volume over time, and we need to clear out for the volume, that is passing the time, multiplying. So we multiply the flow rate times the time, and we got the volume.